Hey guys, and welcome back to Quantic Academy. So today we'll actually be teaching you how to integrate. So if you recall, integration is just the opposite of differentiation. So if I have a function f of x and I integrate it, that'll be the same as finding the antiderivative, which we write as capital F of x. And this antiderivative is such that if I differentiate this, I get back the original function. Okay? So that's what integration is. Now there's two types of integrals. There are definite integrals and indefinite integrals. So the key difference between them is this. So a definite integral has bounds. Okay, it has numbers here. An indefinite integral doesn't. There's no numbers there. Okay? So that means the definite integral actually represents a value. And if we saw from last episode that if we have an integral like this corresponds to the change in antiderivative, okay? And that corresponds to the area. So you got the area under the curve here, and then you got the change in antiderivative. So this will be equal to f of x, capital F of x, evaluated from 4 to 2, which just means the change into antiderivative f evaluated at 4 minus capital F evaluated at 2. However, with an indefinite integral, it doesn't represent the area because you're not integrating over a region. So you're not finding the area under the curve over a region. So it doesn't mean anything. Okay? And the area doesn't mean anything here. And you don't get change in antiderivative when you integrate it. You just get the antiderivative. So this will just be equal to capital F of x. Okay? And also, with a definite integral, you get a definite value, right? I get a number, which corresponds to the area. However, with an indefinite integral, I just got the antiderivative, which is a function. It's not a value. So that's another key difference. Now, I told you that if I find the indefinite integral of lowercase f of x, I get capital F of x. That's not true. Actually, I get capital F of x plus c. And the c here is a constant. Now what that means is just a number. So it's just any number. It can be 1, it can be 2, it can be 0, minus 1/3, 27 billion. It just represents a number. And the reason we put that here is because when you differentiate a number, you get 0. Because recall, differentiating is finding the derivative. Finding the gradient. The gradient of a number is just a straight horizontal line. Right? Y equals 2, for example, is a straight horizontal line. So the gradient is 0. So if you differentiate a constant, you get 0. Okay? And so this is still a valid solution because if I were to differentiate this, I would get differentiate capital F, you get lowercase f, that's by definition. You differentiate constant, you get 0. So I still get lowercase f. I still get this. So this is a solution, right? So capital F of x plus 1 is a solution, capital F of x minus 2 over 3 is a solution. Any capital F of x plus constant is a solution. And so we just write it with a c to represent any constant. However, sometimes it might only ask for one solution. In that case, we just take c equals 0 for simplicity. So it's just capital F of x. Okay? And we don't use c in definite integrals because we're finding the change, we're subtracting. So the c's will cancel out anyways. Okay, so now let's actually integrate functions. So if I integrate 0, what do I get? Well, what differentiates to 0? We just talked about that. Constant differentiates to 0. Okay? So the constant can be any number. It can be 1, 2, 3, 5, 10 billion. They all differentiate to 0. Then now let's find the integral of 2. So what differentiates to 2? Remember, differentiation is finding the gradient of the line, of the tangent line. So what has gradient 2? Well, that's just a straight line. And the straight line will take the form y equals mx plus c. So this will just be equal to 2x. And we put the plus c because don't forget about that. Okay? But from now on, I'll only write the function. I won't write plus c because it gets repetitive. Okay? But in actual answers, write plus c. So now let's try something else. What happens if I... Oh yeah. And also, if you integrate a number, you get that number times x. Because recall, when you differentiate a number times x, you get that number back. So integration is just the opposite, okay? If I integrate 3, I get 3x. Okay. So what happens if I integrate x squared? What do I get now? Well, now this is where we have to use a general rule. So what differentiates to x squared? So let's look at what differentiation is. If we have x to the power of 5, for example, and we differentiate it, we take the power, we bring it to the front, and we minus 1. So this becomes 5x to the power of 4. Okay. So integration is the opposite of differentiation. So what do we do if we integrate x to the power of 5? We do the exact opposite. So instead of minusing 1 from the power and bringing the power to the front, we add 1 to the power. Okay? X to the power of 6. And when we bring the power to the front in differentiation, we're basically multiplying it by the power, right? But so in integration, it's the opposite. So instead of multiplying by the power, you divide by the new power. And so you get x to the power of 6 over 6. And if you try to differentiate this, you get back x to the power of 5. Okay? So when differentiating, if we do the general case, differentiation, we take the power, bring it to the front, minus 1. So you get this. However, integrating, you add 1 to the power, and you divide by the new power. Okay, so that's how you integrate. So if I integrate x squared, I add 1 to the power, that's x cubed, divide by the power, which is 3, so I get x cubed over 3. Okay, if I want to integrate x cubed plus 2x squared, now let's add some bounds, so it becomes a definite integral. Let's do from 0 to 2. Now I have two terms, and remember, if you differentiate two terms, you do each one separately. Same thing with integration, is the entirely same rules, because it's literally the direct opposite. So if I were to integrate x cubed, I would add 1 to the power, x to the power 4, divide by the power, over 4. If I were to integrate 2x squared, I would add 1 to the power, which is 2x cubed, and divide by the power. Okay. And the reason I kept the 2 here and didn't change the 2 here is because, remember, differentiation, if I have like 5x cubed and I differentiate it, I still keep the 5, but I'm still multiplying by the rest. I don't just get rid of the 5. And same thing here, you don't just get rid of the 2, you keep the 2. You keep the 2 here, it's still here. But now it's become 2 over 3. Okay? So the coefficients don't just disappear. And don't forget the plus c. Actually, no, sorry. This is an indefinite. So this is a definite integral. So I evaluate it at 2 and at 0 and find the difference. So I substitute it in. And if I substitute 0 into this, I'll just get 0, so it doesn't matter. So 2 power 4, that's 16, over 4, that's 4. 2 power 3, that's 8, times 2, that's 16, 16 over 3. 4 plus 16 over 3, that's 20 over 3. If I went too fast, please pause the video. Okay, so now let's do some more complicated examples. Let's do this. Square root of x plus 3, 1 minus 1 over x squared. So now we haven't done this kind of thing, right? We've done before where it's x to the power of something plus x to the power of something. So let's try and get into that form. Now we see square root of x here, and that looks intimidating. But remember, square root of x is just the same thing as x to the power of a half. So we got x to the power of something, that's fine. What about 1 over x squared? Well, if we have x squared in the denominator, it just becomes x to the power of minus. So this will just be x to the power of minus 2. So again, it's just x to the power of minus, x to the power of something. So that's fine. That's the form we want. So we have to expand this because, again, we want it in this form, x to the power of something plus x to the power of something, etc. So if I expand this, I get square root of x, square, and this way minus square root of x over x squared, plus 3, and then minus 3 over x squared. So let's do this step by step. First, I'll convert it into powers of x. So root x is x to the power of a half. What's root x over x squared? Well, root x is x to the power of half. If I'm dividing the x to the powers, then I'll just subtract the powers. So it would be half minus 2, which would be negative 3 over 2. No, sorry. Half minus 2. Yeah, negative 3 over 2, sorry. Okay. And minus 3 over x squared. X squared is x to the power minus 2, so it'll just be minus 3 x to the power minus 2. And then don't forget the plus 3 here. Okay. So just do the exact same thing. So even if it's a fraction, decimal, pi, just do the same thing. So you add 1 to the power, 3 over 2, and you divide by the power. Same thing here. Negative 3 over 2 plus 1, that'll be negative half, because if you add I'm adding to a negative number, don't forget. And divide by the power, divide by negative half. Now, I got negative 2 as a power here, so I add 1, I get negative 1. Divide by the power. And then for here, I'm integrating 3. Remember, I told you, if you integrate a number, you get that number times x. Don't forget the plus c. And then, here, I got a fraction in the denominator. I got a fraction in the denominator, so I just swap the fraction around. So this becomes 2/3 x to the power 3 over 2. And then I got minus here, so it cancels. Half in the denominator, so that becomes 2. 2x to the power minus a half. Minus here becomes a plus. So so 3x to the power minus 1 plus 3x plus c. Okay, now I'm just going to convert it to fractions again. So x to the power minus half, that's x to the half in the denominator, and x to the half is root x. X to the power minus 1 is 1 over x, is x in the denominator, so it'll just be 3 over x. And then don't forget plus 3x plus c. Okay, so that's that. Last but not least, I'm going to teach you one more thing, and that is if it's like this. Okay, now in this case, we got a giant fraction. But I wanted an x to the power of something, don't forget. I wanted x to the power of something plus x to the power of something else. And so what we'll do is we will split the fraction. So we'll make it like this. So it'll be 2x squared over root x plus 3x over root x plus 2 over root x. If you watch our how to differentiate video, remember we did the exact same thing when differentiating these large fractions. And integration is just pretty much the same thing, except just the exact opposite. It gets more complicated with more complicated functions, but for these power functions, if you have x to the power of something, then it's very straightforward. It's just the exact opposite of differentiation. So now if I simplify this, root x is x to the power of half, 2 minus a half, that is 3 over 2. And then x over root x, that's x to the power of 1, minus x to the power of a half, that's x to the power of a half. And then I got x to the power of half in the denominator, so I'll be x to the power of negative a half. And the reason I subtracted the powers was because I was dividing by x's. Okay. And now I just integrate, I just do the same thing. So add 1 to the power, that becomes 5 over 2 divided by 5 over 2. Add 1 to the power, that becomes 3 over 2 divided by 3 over 2. And then add 1 to the power, negative a half plus 1, that's half, divided by half, plus c. Now I just simplify. 2 over 5 over 2, that's 4 over 5, because 2 over 5 comes up, and you multiply by the 2, so it becomes 4 over 5. 3 over 3 over 2, the 3's cancel out, the 2 comes up, so 2x to 3 over 2. 2 over a half, that becomes 4, because the 2 comes up as well, so it's minus 4x to the half plus c, and that will do it. So that's it for integration today. I might make a video in the future talking about how to find the area under the curve and all of that. So stay tuned. Thank you guys for watching. If you enjoyed it, leave a like and subscribe, and see you guys next time. Goodbye.